Section 250.92. A2 of the National Electrical Code, NEC, addresses bonding requirements for service raceways, enclosures, and fittings. Specifically, it mandates that where rigid metal conduit or intermediate metal conduit is used to connect the service enclosure to the grounding electrode system, or to connect the grounded conductor at the service, it must be bonded. This bonding requirement applies to all intervening metal raceways boxes and enclosures between the service equipment and the grounding electrode. The purpose of this bonding is to ensure a low impedance fault current path back to the source, facilitating the operation of overcurrent protective devices and minimizing voltage rise on metallic parts during a ground fault. When a rigid nipple is installed between a meter enclosure and the service disconnect, it falls under the scope of Section 250.92. A2. Therefore, the rigid nipple must be effectively bonded to ensure electrical continuity and safety. Bonding bushings are commonly used to provide this required bonding. A bonding bushing is a type of fitting designed to provide a reliable electrical connection between a metal raceway and an enclosure. It typically features a sharp edge or teeth that bite into the metal of the enclosure, creating a secure electrical bond. Additionally, bonding bushings often include a provision for connecting a bonding jumper, which is a conductor used to connect the bushing to the grounding system. The requirement for bonding bushings on both sides of the rigid nipple stems from the need to ensure continuous electrical conductivity throughout the entire raceway system. If only one end of the nipple were bonded, a potential difference could exist between the nipple and the enclosures it connects, which could lead to arcing and create a safety hazard. By bonding both ends, the nipple becomes an integral part of the grounding path, ensuring that any fault current can flow safely back to the source. The size of the bonding jumper used with the bonding bushings is determined by Section 250.66 of the NEC, which specifies the minimum size of grounding electrode conductors based on the size of the service entrance conductors. The bonding jumper must be sized no smaller than the grounding electrode conductor for the service. The installation of bonding bushings must be performed in accordance with the manufacturer's instructions and any applicable local codes or regulations. It is important to ensure that the bushings are properly tightened and that the bonding jumpers are securely connected. Additionally, the surfaces of the metal enclosures should be clean and free of any paint or corrosion that could impede the electrical connection. It is worth noting that there are exceptions to the requirement for bonding bushings in certain situations. For example, if the rigid nipple is very short and is installed with listed fittings that are specifically designed to provide a reliable electrical connection, bonding bushings may not be required. However, it is always best to consult with a qualified electrical inspector or engineer to determine the specific requirements for a particular installation. In summary, Section 250.92. A2 of the NEC requires that rigid nipples installed between a meter enclosure and a service disconnect be bonded to ensure electrical continuity and safety. Bonding bushings are commonly used to provide this required bonding, and they must be installed on both ends of the nipple to ensure a continuous grounding path. The size of the bonding jumper used with the bonding bushings must be determined in accordance with Section 250.66 of the NEC. Careful installation and adherence to all applicable codes and regulations are essential to ensure a safe and reliable electrical system. Grounding and bonding are critical aspects of electrical safety. Effective grounding and bonding practices ensure that electrical equipment and systems are properly connected to the earth, providing a low impedance path for fault currents. This helps to minimize the risk of electric shock, fire, and equipment damage. Grounding refers to the connection of electrical equipment and systems to the earth. The earth acts as a reference point for voltage, helping to stabilize the electrical system and prevent voltage fluctuations. Grounding also provides a path for fault currents to flow back to the source, allowing overcurrent protective devices to trip and to energize the circuit. Bonding, on the other hand, refers to the connection of metallic parts of an electrical system to create a continuous electrical path. This includes bonding together metal conduits, enclosures, and equipment frames. Bonding helps to equalize the potential between these metallic parts, reducing the risk of electric shock if a fault occurs. The NEC provides detailed requirements for grounding and bonding in Article 250. This article covers a wide range of topics, including grounding electrode systems, equipment grounding conductors, and bonding methods. It is essential for electricians and electrical engineers to be familiar with the requirements of Article 250 to ensure that electrical systems are installed and maintained in a safe and compliant manner. Grounding electrode systems typically consist of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. These electrodes are connected to the electrical system using a grounding electrode conductor. The size of the grounding electrode conductor is determined by Section 250.66 of the NEC, which is based on the size of the service entrance conductors. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding system. This includes the metal enclosures of appliances, motors, and other electrical devices. Equipment grounding conductors provide a low impedance path for fault currents to flow back to the source, allowing overcurrent protective devices to trip and energize the circuit. Bonding methods include the use of bonding jumpers, bonding bushings, and other fittings designed to provide a reliable electrical connection between metallic parts. Bonding jumpers are typically used to connect metal conduits and enclosures together, while bonding bushings are used to bond metal conduits to enclosures where the conduit enters the enclosure through a knockout. In addition to the requirements of the NEC, local codes and regulations may also have specific requirements for grounding and bonding. It is important to check with the local electrical inspector to determine the applicable requirements for a particular installation. Proper grounding and bonding are essential for electrical safety. By following the requirements of the NEC and local codes, electricians and electrical engineers can help to minimize the risk of electric shock, fire, and equipment damage. Always consult with a qualified electrical professional if you have any questions or concerns about grounding and bonding. Let's delve deeper into the specifics of NEC Section 250.92. A2 and its implications for bonding rigid metal conduit nipples. This section falls under Article 250, which, as mentioned earlier, comprehensively covers grounding and bonding requirements. 250.92 specifically addresses bonding other enclosures at services. The key phrase in 250.92. A2 is where used to connect the service equipment to the grounding electrode. This means the bonding requirements apply not just to the main service conduit run, but also to any intervening metal raceways, boxes, and enclosures between the service equipment such as the meter enclosure and the grounding electrode or the grounded conductor. The intent is to create a continuous, low impedance path for fault current. Now, consider the scenario with a rigid nipple between a meter enclosure and a service disconnect. Since this nipple is part of the service raceway system connecting the service equipment, the meter enclosure to the service disconnect, and ultimately to the grounding electrode, it falls under the purview of 250.92. A2. The question then becomes how to effectively bond this nipple. This is where bonding bushings and, potentially, bonding jumpers come into play. A bonding bushing is a specialized fitting designed to provide a secure electrical connection between the conduit and the enclosure. It typically features a set screw or other mechanism to bite into the metal of the enclosure, ensuring good electrical contact. Some bonding bushings also include a lug for connecting a bonding jumper. The NEC doesn't explicitly mandate the use of bonding bushings in every situation. However, it requires that the connection be made in a manner that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed on it. This is where engineering judgment and local interpretations come into play. In most cases, especially for nipples longer than a few inches, using bonding bushings on both ends is the most reliable and easily verifiable method to achieve proper bonding. The reason for requiring bonding on both ends of the nipple is to eliminate any potential voltage difference between the nipple and the enclosures it connects. If only one end were bonded, a fault current could still create a voltage gradient along the nipple, potentially leading to arcing or other undesirable effects. Bonding both ends ensures that the entire nipple is at the same potential as the enclosures, providing a safe and effective fault current path. Now let's talk about bonding jumpers. A bonding jumper is a conductor used to connect the bonding bushing to the grounding system. The size of the bonding jumper is determined by NEC section 250.66, which bases the size on the size of the service entrance conductors. It's crucial to use the correct size bonding jumper to ensure it can safely carry the expected fault current. The installation of bonding bushings and bonding jumpers must be done carefully and in accordance with the manufacturer's instructions. The surfaces of the enclosures and conduit should be clean and free of any paint or corrosion that could impede the electrical connection. The set screws and the bonding bushings should be tightened securely to ensure a good bite into the metal. The bonding jumpers should be connected to a suitable grounding point, such as the grounding busbar in the service disconnect. While bonding bushings are a common solution, other methods may be acceptable in certain situations. For example, listed fittings specifically designed to provide a reliable electrical connection may be used without bonding bushings. However, it's essential to verify that these fittings are indeed listed for this purpose and that they provide an equivalent level of bonding performance. Finally, it's important to remember that electrical codes are subject to interpretation by local authorities. It's always a good practice to consult with the local electrical inspector to ensure that your installation meets their specific requirements. They may have specific preferences or interpretations regarding bonding methods. In summary, bonding rigid nipples between meter enclosures and service disconnects is crucial for electrical safety. NEC section 250.92. A2 requires bonding of service raceways and enclosures. Bonding bushings on both ends of the nipple are a reliable and common method to achieve proper bonding. Bonding jumpers, sized according to NEC section 250.66, may also be required. Always consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Section 250.4. A5 of the NEC further reinforces the importance of effective grounding paths. This section states that the grounding path shall be permanent and electrically continuous and shall have the capacity to conduct safely any fault current likely to be imposed on it. This emphasizes the need for robust bonding methods that can withstand the stresses of a fault event. Another relevant section is 314.4 concerning the proper use of conduit fittings. Specifically, it states that fittings used with conduit shall be designed and installed to ensure electrical continuity of the raceway. This applies directly to the selection and installation of fittings used with rigid nipples. Fittings must be listed for the purpose and installed in accordance with the manufacturer's instructions to maintain the integrity of the grounding path. When dealing with older installations, it's essential to inspect the existing grounding and bonding system carefully. Over time, connections can corrode or loosen, compromising the effectiveness of the grounding path. If any issues are found, they should be addressed promptly to ensure the safety of the electrical system. In some cases, it may be necessary to upgrade the grounding system to meet current code requirement. This could involve replacing undersized grounding conductors, adding additional grounding electrodes, or improving the bonding of metallic enclosures. It's also important to consider the environment in which the electrical system is installed. In corrosive environments such as coastal areas or industrial facilities, special precautions may be necessary to protect the grounding and bonding system from deterioration. This could involve using corrosion-resistant materials or applying protective coatings to the connections. The NEC also addresses the use of listed equipment. Section 110.3. B requires that all electrical equipment be installed and used in accordance with any instructions included in the listing or labeling. This means that if a particular fitting or device is listed for use in a specific application, it must be installed and used accordingly. Using equipment in a manner that is not in accordance with its listing could void the warranty and potentially create a safety hazard. In addition to the NEC, other standards and guidelines may also be relevant to grounding and bonding. For example, the Institute of Electrical and Electronics Engineers (IEE) publishes a number of standards related to grounding and bonding, such as IEE Standard 142, Recommended Practice for Grounding of Industrial and Commercial Power Systems. These standards provide more detailed guidance on specific aspects of grounding and bonding and can be helpful in designing and installing complex electrical systems. When working on electrical systems, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and de-energizing circuits before working on them. It's also important to use properly insulated tools and to follow lockout/tightout procedures to prevent accidental energization of circuits. In conclusion, bonding rigid nipples between meter enclosures and service disconnects is a critical aspect of electrical safety. The NEC provides detailed requirements for grounding and bonding, and it's essential to follow these requirements to ensure that electrical systems are installed and maintained in a safe and compliant manner. Bonding bushings and bonding jumpers are common methods for achieving proper bonding, and it's important to select and install these components carefully. Always consult with a qualified electrical professional if you have any questions or concerns about grounding and bonding. The goal of proper grounding and bonding is to create a safe electrical environment. This involves providing a low impedance path for fault currents, minimizing the risk of electric shock, and protecting equipment from damage. By following the requirements of the NEC and other applicable standards, we can help to ensure that electrical systems are safe and reliable. Now consider the practical aspects of installing bonding bushings. Firstly, preparation is key. Before beginning any work, ensure the power is disconnected and the circuit is properly locked out and tacked out to prevent accidental energization. This is a critical safety step. Secondly, inspect the rigid nipple and the enclosures to which it will be connected. Look for any signs of damage, corrosion, or debris that could impede the electrical connection. Clean the surfaces thoroughly with a wire brush or emery cloth to remove any rust or paint. Thirdly, select the correct size of bonding bushing for the rigid nipple and the enclosure knockout. The bushing should fit snugly without being forced. Fourthly, install the bonding bushing onto the rigid nipple, ensuring that the teeth or sharp edge of the bushing make good contact with the metal of the enclosure. Tighten the set screw on the bushing securely to create a solid electrical connection. Fifthly, if the bonding bushing has a lug for a bonding jumper, connect the bonding jumper to the lug and tighten the connection securely. The bonding jumper should be sized according to NEC section 250.66 based on the size of the service entrance conductors. Sixthly, route the bonding jumper to a suitable grounding point, such as the grounding busbar and the service disconnect. Ensure that the bonding jumper is protected from physical damage and that it is securely connected to the grounding point. Seventhly, after completing the installation, inspect the bonding connections carefully to ensure that they are tight and that there are no loose wires or connections. Use a multimeter to verify the continuity of the grounding path. Eighthly, document the installation, including the size of the bonding bushings, the size of the bonding jumpers, and the location of the grounding point. This documentation will be helpful for future maintenance and inspection. Ninthly, remember to apply anti-seize compound to the threads of the bonding bushing and the set screw to prevent corrosion and to make it easier to remove the bushing in the future. Tenthly, always follow the manufacturer's instructions for the installation of bonding bushings and bonding jumpers. The manufacturer's instructions may provide additional guidance on specific installation techniques or precautions. Finally, remember that electrical work can be dangerous, and it's important to take all necessary safety precautions. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work.